and welcome to my video. Alright, we're going to be in 5.1, and let me go ahead and get this all set up. I did have whole PowerPoint kind of laid out so I can go in order, so that's the idea. Let's get started. We are talking about 5.1, using fundamental identities. A couple of things that we're going to know are evaluating trig functions, simplifying trig expressions. We're going to develop additional trig identities, and lastly, solve trig equations. A lot of these are going to be through examples and whatnot. So I will make this particular PowerPoint available to you online as well. Let's begin. Oh, if I cough like crazy, sorry about that. I'm not feeling too up to the weather today for some odd, unapparent reason. So, first off, we're going to be identifying U. Now, U is going to be a new type of value. Nice, nice. I forget what to do here. So, U, what is U? Well, U is going to be equal to, a little bit crooked here, U is equal to an angle, so it could be an angle. It could be a real number. It could be a variable. And it could be a constant as well, such as pi or anything like that. So there's a few other things, which I guess would fall under real numbers. But there's a few other things that U can be. So we're going to leave U as this. We're not going to use theta. We're not going to use anything of that sort. We are going to leave it as U. So what's required of you to know? U, get it? U. What's required of you to know in this particular section? Well, we are going to be using algebraic skills. And I'm sorry, but this will be a long video, so be prepared. Okay, so certain things like finding special products, we are going to be factoring. We are going to be performing operations with factorial expressions. We're going to be rationalizing denominators, which is a big one. And all sorts of other things, mainly solving equations. Solving. Okay? So a couple of things that you need to know. Let me change this to another ink color, like white. There we go. So make sure you brush up on these particular skills, because we will be using them. So let's talk about some identities. Okay, I'm going to give you some identities, and these are all located on page 376. And make sure you reference 376 when you are doing your homework assignment. So first one are reciprocal identities. Those are sine of U, and hopefully we remember that sine of U or sine can be written as 1 over values, and cosine can be written as 1 over sine. So sine can be written as 1 over 1 over cosecant U, and vice versa, cosecant of U can equal 1 over sine of U, which you are familiar with this one. This one you are a little bit unfamiliar with. We have now cosine. Cosine of U is equal to 1 over secant U, as well as secant of U equals 1 over cosine of u. And these are all reciprocals, hence the name reciprocal identity. The last one we have is tangent. So tangent of u equals 1 over cotan of u, and cotangent of u equals 1 over tangent of u. So we should have seen these before, but we will be using these particular ones to help us out. So these are the reciprocal identities. Next, quotient identities. And of course, go back if you need to stop and write those down if you're taking notes. Quotient identities. What divides what? We have two of these. We have tangent of u. Tangent of u is equal to sine over cosine. Shouldn't be too new. And then we have cotangent of u, and that is the same thing but flipped. So it's going to be cosine of u. Okay, so these are quotients. Quotient means dividing or divisible. And notice that one of the things that I'm going to say is that it's important to get things into sine and cosine to make it simple. We also have the Pythagorean identities, and we've seen these before. This is sine squared u plus cosine squared u equals 1. We can also rewrite these as, you can subtract it over, so other ones that you might have seen are that cosine squared u equals 1 minus sine squared u, and vice versa. So this can be manipulated into other situations, but I'll leave it as that. We have another Pythagorean identity that's new, 1 plus tangent squared u, that equals secant squared u, and I'm sure we'll come back to that and why that works, as well as 1 plus cotangent squared u equaling cosecant squared u. So these are our Pythagorean identities. And we'll be looking at these and using substitution and all sorts of stuff. All right. Continuing, we have cofunction identities. Now, cofunction identities are dealing with shifts, and shifts from left to right. We kind of discovered this before, but we found that if you shift certain things like left or right, it turns into our previous image. So, for instance, if we take sine and we add pi over 2, or we go one way with pi, we take u and subtract it from pi over 2, that equals cosine of u. And on a graph, what that looks like is as if you have a graph over here, and here's sine, and we've shifted it. It turns out that we shifted so much over, so let's change the color. We shifted so much over that it comes up and it hits here. So it's gone back. This distance right here is pi over 2. And so now it turns into cosine. Okay? So, moving on. We have sine. We have cosine. Cosine is the same thing. Pi over 2 minus u equals sine of u. We have tangent. Same thing occurs here. Pi over 2 minus u equals cotangent u. We've seen this before. And it's vice versa with cotan. And lastly, we have secant, which should be relatively new. Secant shifted pi over 2 minus u equals oops, dang it, keep doing that. want to write cosecant, but I the wrong things. Cosecant u, and then did it again. Cosecant u, cosecant pi over 2 minus u, that equals secant u. So these are all pretty important, especially when we're graphing. It's also handy with right triangles and dealing with right triangles. We can discover that a little bit more some other time, but not today. So let's move on. Even and odd functions. Even and odd. So these are really handy. Sine of negative u, we can actually write as negative sine over u. That's a function here. We have cosecant negative u equals negative cosecant u. We have secant negative u equals negative secant u, but that's positive. Okay, so there we have a different type of function. This is cosine of negative u, turns out to also equal positive cosine of u. And then tangent negative u, that is a nice function here, negative tan u, and cotangent falls suit as well. I wish there was like a quick button I could just press like P for pen and then have it go to pen, you know, and E for eraser. Okay, so these identities will pop up. So I want to head back just a little bit to our Pythagorean identities, and just to note that some of these can be rewritten. First off, we can write sine squared u equals 1 minus cosine squared u. We can write cosine squared u equals 1 minus sine squared u. And then we can do the square root of these as well. So we have sine u equals the square root, of 1 minus cosine squared u. And we can write cosine u equals the square root, of course the plus or minus here, I keep forgetting that, plus or minus 1 minus sine squared u. So I'm just taking this because we know that sine, this is just a little side note, sine squared u, that equals, in parentheses, sine u squared. And of course that goes with every single thing else. So what we've done is just square rooted both sides so we can get something else. Alright. And you can see there's one more. It's basically tangent, but you can figure it out. You'd subtract 1 over and you square root it. So it turns into tangent square, or dang it. Tangent u equals plus or minus the square root of secant squared u minus 1. Same thing with cotangent. Sorry about that, it got a little messy. Alright, let's move on. So let's do some examples. But first, here's some hints. Okay, because you're going to have all sorts of different situations. So make sure that you are working either on one side or the other. Please don't transfer back and forth both. Okay? You're either working on the left side or you're working on the right side. Okay? Do them independently and then compare. You might have to do one, see where it goes, do another one, see where it goes, and then find a consensus somewhere. Okay? Change all terms to sine and cosine. I find this super handy So we can get things into a certain expression so we can evaluate them. Otherwise, we'll have issues. Use page 376 as a reference. This should be a reference. Get your phone, take a picture of it, whatever. It's important. Or you can make a note card, which can be used on the test. Work on the hard side first. Okay? There's always one side that's a little bit harder than the other one. So, work on it first. And remember to be patient. These do take a little bit of time. Okay? These can be frustrating, so make sure you take your time and take breaks when you need to. So, I would say this one is number 1. And we're moving on. Examples. Using identities to evaluate functions. Okay, so let's get the right pen color. And if you're wanting to take a break, now's a good time because we're going to go right into it. God, I hope I pressed record. I think I pressed record. Oh no, keep. Did I press record? Whew. Sheesh, freaked me out. I just did all that and talked all that. Oh my goodness. Alright, so let's keep going. Let's start with, oops. Nope, we're not going to go there. We're going back. Grab a pen. Bink. Change my color. Bink. And let's begin. So your problem is, use secant u set equal to negative 3/2 and the fact that tangent u is greater than 0 to find all 6 trig functions. Okay? So let's look at these trig functions. So first let's look at cosine. Okay? We're going to do cosine, we're going to do sine, we're going to do tangent, we're going to do all those. Secant, cosecant, and cotangent. Cosine u is equal to what? Well, we can go back over to our reciprocal functions and say, okay, cosine equals 1 over secant. Hey, that's actually super helpful. So let's go ahead and take that. No, not the death spiral. Come on. Come on. Oh, I can't believe this is happening. Alright, well, this is take 3. You missed take 2. It was pretty bad, so don't judge. Anyway, let's continue. I screwed up, so let me first focus on this value. I changed this. Okay, it didn't work before because we needed a value greater than to make it even work. Okay, because our hypotenuse has to be greater. So anyway, let's go through this one more time quickly. Cosine of u equals 1 over secant u, and secant u is equal to 1 over negative 3/2, so we end up with cosine u is equal to negative 2/3. Alright? And this is opposite over hypotenuse. Now you're welcome to think of this as a triangle, but we could evaluate it using trig functions as well, so we're going to do both. Cosine is, adjacent over opposite. This is going to be negative 2. This is going to be 3. So we need to figure out what this value is to find the rest of our values. Now this says tangent is greater than 0. So that means this would have to be a negative number as well. So we know that tangent is going to be a negative number. Let's use a Pythagorean identity to solve it. It's kind of a long way, but that's okay. Sine squared u equals 1 minus cosine squared u. Now remember, cosine squared u is the same thing as cosine u in parentheses squared. So I'm going to go ahead and put sine squared u equals 1 minus, and we know that cosine is now equal to this value, so we get negative 2 over 3 squared, which is 1 minus 4 over 9, which ends up being a nice number, which is 5 over 9. Now this equals sine squared. So to figure out what sine is, we square root it. So sine u equals now the square root of 5 over 9. Oh, sorry. 5 over 3. I just square rooted the top and the bottom if you're paying attention. Now it says right here that this is going to be a negative number. So if that's a negative number, then this ends up being a negative number. When we square root something, we square root plus or minus. So we're taking the minus of that. So we have sine. We have cosine. Let's do the other ones. Now everything else can be derived from this. Okay? Excuse me. Burped. So next we have sine, cosine. Let's do tangent. Tangent of u is equal to sine u over cosine u. This equals negative square root 5 over 3 over negative 2 over 3. And you can do some math there. The 3's cancel, the negatives cancel, and we end up with square root 5 over 2. We have cosecant of u. That's just equal to 1 over sine u. And sine u is this value. So we end up with a nice number of 1 over negative square root 5 over 3. That was a joke. Which equals 3 over, put the negative out front, square root 5, which ends up being negative 3 square root 5 over 5. Okay? Tangent. Now we have secant u. This is 1 over cosine u, which equals 1 over negative 2 over 3, which equals negative 3 over 2. Hey, we've already done that one. Why did I do that again? I don't know. Last one is cotangent u. Cotangent of u is negative 2/3 over negative square root 5 over 3, which ends up canceling the u's. We get our negatives to cancel. We get 2 over square root 5, which I don't like to leave the square roots in there, so we end up with 2 square root 5 over 5. Multiply the top and the bottom by square root 5. I did that up here, up there. Alright, so now that we've gotten through that, let's simplify some of these. Okay, so let's do that. Now we're going to look at different ways of doing things. So first off, let's take this thing right here, this sine x cosine squared x minus sine x. Okay, now we can go ahead and set this equal, and we're going to make this nice. How do we do that? Well, we're going to factor out a sine. So this equals sine x cosine squared x minus 1. Okay? So we factored. Next, what do we want to do? Well, we want to say that these two things are equal. That's why I put this on this side. So we need to use the distributive property to simplify. Now, why would I use the distributive property? Well, I want to take out a negative. So here's what I'm going to do. I'm going to take out negative 1, put sine x, and that makes our cosine negative and our 1 positive. So I want to rewrite this as 1 minus cosine squared x. Now, why the heck did I do that? I did that, so this is take out negative. I did that so I could I'm getting a phone call. Hold on a second. Keep. Oh, crap, I missed it. Alright, they're probably leaving a message. Alright, so where were we? You take out the negative, and take out the negative, so this turns into our Pythagorean identity. Okay? This 1 minus cosine squared x is equal to sine squared x. Oh, poop. So, we end up getting negative sine x sine squared x together. Okay? So I'm going to put sub Pythag identity. Okay? So we substitute it in, and we find out that when you multiply these together, this is negative sine cubed x. Sine cubed x. We have a simplified version. Nothing else simplifies even more. Okay? So, we can look at some other ones, but let's go ahead and I want to skip this, and I'm going to go to the verifying the identity. Alright, hopefully they left a voicemail. Alright, so we have sine theta over 1 plus cosine theta plus cosine theta over sine theta equals secant theta. So how do we simplify this? Well, let's take one side at a time. So we're going to take this side and we're going to start it out. Okay? So what do? Well, we need to rationalize these bottom parts. Okay? How do we rationalize these bottom parts? Well, we take sine theta over 1 plus cosine theta, and we're going to multiply that by sine over sine. And you can multiply this by, we're multiplying it by the common denominator. And the common denominator is going to be 1 plus cosine times sine theta. Okay, we're multiplying the top. And then this side, we need to take cosine theta over sine theta and multiply it by 1 plus cosine theta over 1 plus cosine theta. Once again, I'm creating a common denominator. Okay? And we go back to the hints that I lost, but this is definitely the harder side, so we're doing that. So let's combine like terms. And we have sine, that's going to be sine squared theta. And this one we can distribute, but let's go ahead and leave it. Plus cosine theta 1 plus cosine theta all over 1 plus cosine theta, put that in parentheses, and sine theta. Okay? So now that we've done that, we can see, oh, let's distribute. So we have sine squared theta plus cosine, should we put them next to each other? Sure, let's put them next to each other. Cosine squared theta plus cosine theta all over 1 plus cosine theta sine theta. Perfect. Alright, so now that we've done that, we go to our Pythagorean identities and we say sine squared theta plus cosine squared theta is 1. Okay? So we can rewrite this, and I'm going to go ahead and just put it equal right here, but you're not supposed to, but put it equal right here. I would like you to stay on the same side, so I'm going to go to the next slide. I don't have enough room. This whole thing right here, Pythagorean identity says it equals 1. So we get 1 plus cosine theta, which is what's left over 1 plus cosine theta, ooh, interesting, times sine theta. And what happens? These cancel out. And we end up getting 1, I'm going to put this back over here, 1 over sine theta equal to secant theta. And this is one of our identities, so we're good. This is the reciprocal identity. And so we have shown enough information. Seems like a lot of work, but it's helpful. Okay? Some problems that would be very similar to this one would be like 56, 57, 55. All of those right there would be good. Also, you can take a look at 48 and 47 and 46. Those ones are all kind of like this. Huh. All right, perfect. All right, so now let's do some factoring. All right, so let's take A. We have secant squared theta minus 1. And we're going to have B over here. We have 4 tangent squared theta plus tangent theta minus 3. Okay, so we can see this as similar properties that we've seen when we were doing Algebra 1. Okay? And Algebra 1 is just the same thing as pre-calculus, of course, so I have to compare them. Anyway, this is the same thing as secant theta squared minus 1 squared. And if you remember that if you have this particular scenario, this is the same thing as secant theta minus 1 and secant theta plus 1. All right? And we have it factored. That's how we factor that kind of thing. Okay? For this one over on the other side, well, we have a little bit more. Okay? This is a function that's kind of an ax. It's an ax squared plus bx plus c, but we have to identify what x is and really what a, b, and c are. I don't like this color. Let's do a lighter color. Like that. All right? So we rewrite the expression to fit what we want it to look like. Okay? And it turns out that it does work out pretty nicely. Okay? So let's go ahead and rewrite it. Two numbers that multiply together to be 3 and add together to be tangent theta. Sounds kind of funny, but what happens is that we end up getting, I'm sorry, not 3, but these two multiply together. So we can do 12 tan as well. So let's go ahead and rewrite this as tangent, no, dang it. Now I'm rambling. We're going to rewrite this as 2 tangent theta squared plus tan theta plus negative 3. Now once we do that, we can see that this factors nicely. It's 4 tangent theta minus 3 times tangent theta plus 1. So we're not really doing that much different. It's the same thing as two numbers that multiply together to be 12 and add together to be the other value. I'm going to move on. So let's try another one. I think it would be essential if we do. Alright, so let's take the next problem. Cosecant squared theta minus cotangent x. Oops, these are x's, not thetas. Well, shoot. So cosecant x, and that minus 3. Alright, so we have an identity that we can change here, so these will work out nicely. So let's go ahead and change this. That's an arrow, by the way. Let's change this to 1 plus cotangent squared theta minus cotangent minus cotangent x minus 3. And then we can rewrite this as cotangent squared theta minus cotangent x, and now we can combine this as minus 2. So we have to think about how this would work out. We have factors here. They have to multiply together to be cotangent theta, so that's going to be cotangent theta, and this is going to be cotangent theta. They have to add together to be 1, a negative 1, and then they have to multiply together to be a negative 2. So two numbers that would work would be negative 2 and positive 1. Okay? So that was a little bit more smoother. So this is a good reference. Problems that look like this would be problems such as, let's see, excuse me, numbers 63 through 70. We'll have lots of factoring in there. Okay, so we're moving on. Let's simplify another trig expression. Here we go. See, we want to simplify sine t plus cotangent t, and once again I said t was okay to use, variables are okay to use, and cosine t. So we want to try to figure out how to simplify this. So I'm going to go ahead and set this equal to our self. Okay? So we're going to set this equal, and I'm going to bring this over here, and we can change cotangent, and like I said before, we should try to change things from sine to cosine to tangent and stuff like that. So we get sine of t plus. Now let's change cotangent to something that we know, which is cosine over sine. So we have cosine t over sine t multiplied by cosine t. Okay? So we have that, once again. And now, let's change the denominator here so we can actually have something that works. Okay? So if we're going to change the denominator on this side and combine like terms, we should probably have this as a sine. So we have sine squared t now, because I'm multiplying by sine, plus, and I'm going to go ahead and simplify this as cosine t, or cosine squared t over sine. And now we can combine these. Okay? So we end up getting sine squared t plus cosine squared t all over sine t. And which identity do you think we want to use? Well, how about to use the one that sine squared t plus cosine squared t equals 1. So we end up with 1 over sine t, which in turn turns out to be cosecant t. And that is a simplified version. Can you believe that this came to be this? End of slideshow. That's not what I want, but I'm going to keep this. I'm going to go ahead and save because we don't want it to crash. Add another slide here. Let's add 2 slides just for fun. We might have to add 3 slides. And let's go back to it. Okay, so keeping with this role, let's go ahead and rewrite a expression. Okay, so let's do 1 over 1 plus sine x. And we want to rewrite this so it's not a fraction. Okay, so what do we need to do? Well, first thing we need to do is get rid of this thing on the bottom. So we're going to go ahead and set this equal, and we have 1 over 1 plus sine x. And how do we get rid of stuff on the bottom? Well, we multiply it by its reciprocal, 1 minus sine x. And we have to do that by multiplying the top and the bottom by it. Why are we doing this? Well, we'll find out. By multiplying by its reciprocal, what we end up doing is we end up getting what that value is. And if you go and you multiply it through, just like factoring, first, outside, inside, last, we FOIL, excuse me, not factor, we get 1 minus sine theta. Great, I changed it to theta, so I'm going to go ahead and erase that. And I will go back here, sorry. Sine x, that's on the top, over, this turns into 1 minus sine squared x. We have an identity that says 1 minus sine squared x is equal to cosine squared x. So we get 1 minus sine x over cosine squared x. All right. So let's go ahead and separate these out. This is 1 over cosine squared x, 1 over cosine squared x minus sine x over cosine squared x. And we're running out of paper, so let's go ahead and move this right here. And we know that 1 over cosine squared x actually leads to something that is actually pretty nice. Okay? We get 1 over cosine squared x equaling to cosecant, or excuse me, secant squared x. So this equals secant squared x. Now what about this junk right here? Minus sine x over cosine squared x. Now the cosine squared x, there's 2 of them there. So we need to get rid of 1 of them. Okay? So we're going to set this equal to secant squared x is already done, but what is one that's pretty obvious? Well, that's what sine over cosine. And let's rewrite this now by multiplying it by something. Well, there's 2 cosines, so let's write a cosine right here. And we multiply sine by something. Well, let's multiply it by 1. And we see that this is tangent, and this is secant, with our secant squared x right above. And we have done it. No fractions involved. Right? And you can do more problems like that. That would be similar to ones like 79 through 82. Okay? Ah, dang it. I thought I was How'd that happen? Just drag this right there. Okay. So, we have one more problem. It says use substitution. And substitution is pretty tricky, but I think you'll figure it out nicely. It's in calculus it's called use substitution, but we're going to go ahead and say use substitution that x equals 2 tangent theta, where 0 is less than theta, which is less than pi over 2, to express that square root 4 plus x squared as, to express it as a trig function of theta. It seems kind of silly to do, but whatever. So we have the square root of 4 plus x squared, and we know that x equals 2 tangent theta. So we want to write this in its simplest terms. So we were going to substitute that value in. So we square root 4 plus, and now in parentheses, let's put 2 tangent theta squared. So I'm substituting this value in right here. I substitute it in. I square both of them. I get square root of 4 plus 4 tangent squared theta. And now I'm going to simplify it just a little bit more. I'm going to take out a 4 from each one of these to go to a Pythagorean identity. So we're going to take out a 4. We get 1 plus tangent squared theta. And we can look in our Pythagorean identities and realize that 1 plus tangent squared theta is equal to secant squared theta. So we get square root of 4 secant squared theta. And now that this is a perfect square and this is a perfect square, this equals 2 secant theta. Those work out pretty nicely. So that's wonderful. Yay. Okay, so your homework will be texted to you. I need to compile it. Actually, I could probably do it right now. I'll pause the video and then poof, your homework will be back. Alright, there it is. It's quite a few problems, but you've had 2 days off, so enjoy. We'll be discussing